I really like chain, so I've used chain mechanisms on a lot of my clocks and arcade machines. So I didn't realise quite how many sprockets I'd accumulated until I hung them up for this video. This video is really a sort of overview of my experience of using chain and belt drive over the years. If you want to skip to a particular chapter, here are the contents. The most familiar sort of chain is bike chain, and although we take it for granted, it's actually quite extraordinary stuff. It's amazingly efficient at transferring the energy of pedalling into the wheel. It's actually up to 99% efficient, much better than belt or gear drive. And both roller chain and bull race bearings were invented for bicycles in the late 19th century. People have tried belt drive and gear drive over the years, but chain has really never been bettered. Quite recently, a bike sharing company in London tried gear drive. There's obviously an advantage to make it all robust because everything could be enclosed. But with two sets of bevel gears, it was a lot more hard work to pedal, and their later models they reverted to tried and tested chain. Well, Leonardo drew bike chain, but at the time there wasn't the technology to make it. So the earliest sort of chain that was actually used for transmission is traditional chain. It was made of wrought iron by blacksmiths, and this chain is still used for this in this wonderful tool called a chain block. It's one of my very favourite tools. So at the back there's an end loop of chain. This is geared down to move the stronger front chain very gradually, but with enormous power. So if I sit now in my bosun's chair, I will be very easy. I can effortlessly lift myself up. I could actually lift my great big old lathe at the back there just as easily. But what's really gorgeous about it is that I can adjust its position so precisely, much more precisely than any powered hoist, just a fraction of an inch. So in the Industrial Revolution, people tried all sorts of different designs of chain, but what really made the biggest difference was bushed chain. So the pins, instead of just making contact with the side plates, now could make contact all the way through in this bushing. So this much larger area of contact enabled the chain to take much greater loads and also to last much longer. It was invented by Hans Reynolds, who founded the Reynolds Chain Company in 1880, and immediately used on Starkey's safety bicycle. So the way that I use chain in my machines is quite similar in a way. It's usually to connect a motor to a mechanism, and it's useful being able to put the motor somewhere out of the way, and sometimes it's useful to be able to reduce the speed. Actually, there's much more power than I need in a chain this size, so I find that I often use a much smaller size of chain, this 6mm stuff. With small chain, the sprocket wheels are much smaller, so you can reduce the speed much more compactly than is possible with large chain. And of course the sprocket wheels themselves can be the basis of all sorts of mechanisms. Then chain can also be great for linear motion, like these cars in my Trust Wildlife machine.
They then just get stuck in traffic jams, and because they're unable to fly, they just stuck. Bonkers. Bonkers.
But most of all, I love chain because it's so amazingly forgiving. I mean, who would have thought that derailleur gears could possibly work? Just shoving the chain off the rear sprocket and hoping it lands on the next one, particularly when you're going from a small one up to a big one. The sprocket wheels don't even need to be that precise. I even cut a few with an angle grinder when I was younger. And recently I've been cutting quite a few with my plasma cutter. Though plasma cutting is much less precise than laser cutting, the sprocket teeth just seem to fit fine. You know, chain doesn't have to be tight to work. It's quite extraordinarily flexible. I do quite unlikely things, so if I can just hook it over another sprocket up there, and it's quite happy like that. And over here, I've just got a sprocket tied to a bit of string. This is slightly more tricky. I don't know if I'll get this to work. Oops, no, I think I have to get it right under there. Oh God, no, maybe not. Yes, there we go. And I don't know, it's just, it really just wants to work. Choosing what size chain to buy is confusing because there's so many different sizes. The Americans still use imperial sizes, so there are two whole ranges. So the two important dimensions for a chain are the pitch, which is the distance between the pins, and then also the width between the inner faces of the inner links of the chain, which is also, of course, the width of the sprocket teeth that it can run over. Anyway, the smallest one generally available is a 5mm pitch. Very beautiful stuff and still amazingly strong. This will carry a load of over 20 kilograms. But the drawback of this is it's very expensive. I don't think the manufacturing can be fully automated, so some of it's done by hand, I think. So this is one up. This is 6mm, and I use a lot of this this chain. This is where I used to get confused with the American sizes with 1/4 inch because the sprockets aren't interchangeable. In the end, I threw away all the 1/4 inch ones I had because I got so confused. And then there's 05B, which is 8mm. Then there's 06B, which very confusingly isn't quite 10mm. It's 3/8 of an inch, or 9.525mm. And they're the three sizes that I tend to use most. These ones here are all 1/2 inch or 12mm. This is bike chain, and this is a good way. You can see how much thinner the bike chain is than the industrial version. It's just much wider that way. This is motorbike chain, which is even wider still. The largest chain that I have is got a 1-inch pitch. Extraordinary, lovely stainless steel. and I found in the scrapyard and couldn't resist. I've never used it though because it's unbelievably heavy. So yeah. Before leaving chain sizes, I should mention that there are various other exotic sorts of chain, like this rather beautiful leaf chain. I don't know what this particular one came off, but on a large scale they can carry particularly large loads, so they're used on things like forklift trucks and stuff like that. Then there's duplex chain, which is just 2 runs of chain together really. You can even buy triplex chain. Again, the advantage of this is it makes it stronger to carry bigger loads. At the other end of the spectrum, this is my very tiniest chain. It's the fuse chain in this old pocket watch from about 1800. I couldn't believe it. I'd just never seen chain so tiny. Then there's a variety of very light duty chain for sort of model making and stuff. And these chains, they're sort of basically they're made out of wire, bent a bit like jewellery chains, but there's a surprising amount of strength. They're made of steel. This is the most common sort, though you can get plastic ones as well. Then you can also use this sort of chain, the sort of chain on roller blinds for transmission. Again, I haven't done it myself, but out of curiosity, I bought some giant 6mm ball chain just to play with. And it's rather satisfying. And of course the advantage of this stuff is that it can go round corners. So it could go round any sort of 3D path. I just cut the sprockets for these out of Delrin. I drilled holes through Delrin and turned it down on the lathe. So different things to consider. The price makes surprisingly little difference. A 5mm reel of the tiny chain, the 6mm, isn't much different from a reel of the 10mm. There's more metal in the bigger ones, but many fewer links, so there's less to manufacture, it's less complicated. Load, well, for things I make, I don't usually come near to their rated load, so that's not often an issue for me. Obviously, if you're tight for space, the 6mm one is the one to go for. Sprockets are all smaller, everything can fit into a nice tiny space. I think perhaps it'll come clearer with the examples in the rest of this video. Bike chain, you just buy enough for a single loop of chain around the rear wheel and the pedals, but more generally you buy chain in boxes of 5 meters. Some places do sell less, but the box is a cheaper way of buying it generally. So the first thing you have to do is to get the right length, cut it to length, which you do by punching out a pin. So I just have a bit of metal with a hole in that I can lay the chain on top, and then knowing that there's a hole underneath here, I can then punch the pin through. Oh, I should say, yeah, conventionally you use one of these things. This is a chain extractor, it's called. And this works okay for bike chain and larger chain, but it doesn't really work for small chains like the 6mm and the 8mm. So that's why I always resort to punching out the pins. Okay, so I start by getting the pin down to the level of the plate. then it can be a good idea to use a centre punch just to get it a little bit below the plate. Now you can put in a parallel punch, and now it can't slip out of the way. And there's your chain split. So then you've got to join the ends. So the conventional way to do this is with a split pin. And you have to do this on a bike because you've got to get it round through the frame. But on these smaller sizes, these spring clips vary quite a lot. Sometimes they're just right and they're easy to do, but sometimes the spring is just a little bit too powerful and they're very difficult to get in. I've lost count of the number of these spring clips that have just pinged somewhere and I've never been able to find. Anyway, we'll try one. So you put the outer plate over, and then spring clip on top, and then try and yeah, that went very well. But as I say, it's quite hit and miss, this. So I've rather taken to my own way of doing this. So when I first split the chain, I do it slightly differently. Let's see what to do on that one. So I'll do the same thing, start off exactly the same way, pushing the pin flush with the plate to start with. That didn't work quite so well that time. That's it. Get the pin punch. Now this time I'm only tapping very gently because I don't want the pin just to fall out the other side. I'm going to try and leave it attached to the far plate, and this is not as difficult as you might think because the pin flares out at the edges because of the rivet, and so quite lightly now I can give it a little sort of wrench, and that's what I was trying to achieve. So then you can end up with a chain that has got a smaller link of the chain on one end, and you've got the bigger link with the pin sticking up. So then of course it's not that difficult just to, in theory, just to punch the pin back in. A little bit stiff to start with, often then you can just sort of wiggle it. Now you might think this isn't very secure, but I've never ever had one come undone, and it does seem to work perfectly well, and it's just very adaptable. Of course the drawback is you can only do this on the bench, so if you need to assemble a chain in situ, then you do use the links. The one other thing to say about adjusting the length of a chain is that you can buy these useful little things called half links. So you can see the wider link of the chain goes down to a neck, and this means that you can adjust the total length of your chain more accurately. This is 8mm chain. You can only cut it every 16mm really to fit, but using one of these you can adjust it to within 8mm. If you've got your run of chain, you've then got to decide how far apart the pulleys should be. Of course the chain will run loose or it will run tight, but actually I always make one of the pulleys adjustable. I find different mechanisms vary in how tight they like the chain to be. I mean, theoretically, chain should run almost tight, but I very often find it runs better a bit looser. So I cut these slots on my milling machine, but if you don't have a milling machine, that's not the end of the world. The alternative is just to cut oversized holes, and then they could be even bigger than that if you need. Then you put a large penny washer over the top, and you then still have a reasonable amount of adjustment is possible. So I'll just tighten these up, and there's the tension chain. Well, for longer runs of chain, or chain running over a lot of different sprockets, I use a different system. I have a lever arm with an idler sprocket with a spring on the end, so I can show you the general idea. I just made a hole in the wood here. It's the same idea as the spring arm on a bike's derailleur gears that keeps the tension as the chain jumps from one sprocket to the next. The good thing about this is the tension is more adjustable. So then I often find it useful to attach things to chain, to make little things move along a track, or to make larger things move. So the best way of doing this is to buy proper attachment chain. It's lovely stuff. This is the smallest size they do attachment chain for, the 8mm spacing, and I have bought it occasionally. So like the treadmill that the zombies walk on is made of this bought stuff, but it is expensive. It's sort of £50 to £80 a metre, and takes a while to come because it's custom made. So it's very tempting to make my own. So there are two ways I've tried this. This is the neater way, which is to use the connecting links. So you just drill 2 holes in a bit of steel to replace one of the outer plates, and then put the spring clip over the top. And this would be great if I didn't have such trouble with these spring clips. So I have to admit that I very often resort to welding my own attachments, and it looks appalling, my messy welds, but they do seem to be strong enough. I haven't had any problems with the chain coming undone. This is particularly messy because I just made it for a prototype. It was the prototype for the zombies, so there was a zombie attached to each bar. Actually, it's a lot easier if you use the one size bigger, the smallest size that attachment chain is made for, the 8mm chain, and you can get welds that are considerably neater. So again, I drill a plate with the holes the right spacing, and these need to be the diameter of the pins, so you can they fit nicely over the pins like that. The other thing is I don't put anything underneath, so there's a bit of swarf or sort of bit comes out the back, which is useful to hammer over before you actually weld. So now I'll try and weld this and see what a mess I make of it. you can see now they're in pretty good fit, and that makes when you're welding, that makes it much more likely that it's all going to the weld's going to flow from one bit of metal into the next. I'm going to TIG weld these together. So there's the finished weld, not too embarrassing. And the chain's still perfectly flexible. I've used this on many machines, including the COVID window display I made for Novelty Automation. In this machine there's a very long length of chain, so there's a little brass channel for the chain to run in, just to stop it slipping from side to side. Oh, I forgot one other way of attaching things to chain, which works on bigger chain, and that's just to remove one of the pins and put a bolt in instead. It's a very quick way to attach things to a chain. And this is seriously big attachment chain. It's from an overhead conveyor system. Amazing stuff. In fact, just conveyor catalogues are absolutely fascinating. We used it to make a dog run along a track. The big drawback of chain is that it's so messy. If you've ever had a chain come off your bike, you'll know you can't avoid getting covered in grease. This chain, to work properly, has to be oiled, and bike chain particularly has a really hard life because it picks up dirt from the road all the time, and what happens is that it slowly stretches. This happened to a bike of mine when I was in my 20s, and I didn't know this at the time. The chain just kept falling off the sprockets. It was maddening. And it's also happened in the housing ladder.
Congratulations! The house is yours.
Hooray!
The two halves of the ladder on the housing ladder machine are connected by this chain that runs over to sprockets. I had a lot of trouble with this. I completely underestimated the load it was under. So first it was Dyneema rope, 12mm rope, but this stretched, kept stretching, so I was having to adjust the machine every week or two. So then I replaced it with 10mm chain, 06B, and that was better. But the machine got very dirty inside. There was a lot of grease and iron filings, and eventually it started making weird noises, and I couldn't think what the matter was, so I stripped it down, and where have I put them? I found that the sprockets had completely worn. That's what they ended up like. That's how they began. So this is Mark III now. What I did was I replaced the little bits of chain that run over the sprockets with a special chain called marathon chain. This costs a lot more, but in this case it's been brilliant. It's really done the job. There's no more grease and iron filings in the machine, and I've had no trouble for the last couple of years. In retrospect, motorbike chain might have been the best solution. Each link has O-rings to actually seal the grease inside. But of course these are very bulky. Fortunately, the chain inside most of my machines are so lightly loaded that lubrication's less of a problem. But if it is, there's an alternative to chain. which is toothed belt. And there's an equally vast range of different pitches and widths and everything available. The belts themselves are rather clever. Embedded in them they have strands of either really strong fibre or sometimes stainless steel. And these strands are wrapped round and round and round the belt alongside each other. The drawback is it makes it strong, but it means you can't cut the belt. You just have to buy them in the fixed lengths that they come in. I used to use quite a lot of toothed belt, but I had problems with the belts wearing. Initially it's something else in a machine jams, but then if the motor keeps running, the sprocket surprisingly quickly wears away the belt till you get a sort of almost a bald patch. There's a little bit that's happened on there. There's not much left of it. Another small thing about toothed belt is that these little sprockets, they come with steel washers sort of pressed onto the sides as guides, and I find they quite often come off. This is the solution, is quite simply to dot punch around the aluminium. It sort of spreads it enough to keep the side washer in place. So recently I've mainly just been using the very smallest tooth belt, a Synchromesh 2.5mm pitch. Its breaking strain is over 10 times less than 6mm chain, but for small things it's just that much neater and more compact. The one thing about it is that you can't run tooth belt slack like this because it just jumps over the teeth. You have to run it taut. Tooth belt can actually be run incredibly tight. I had no idea until I opened up my plasma cutter. You sort of play it like a musical instrument really. So like chain, belt can be used for linear motion as it is for driving the cutter arm along the bed of my plasma cutter. And used in this way, because the belt only travels from one end to the other, you don't need a full continuous loop of belt. In fact, it's broken here. So then that's the advantage, that you can use any old length. The drawback of this is that the bed actually only moves about 600mm, but you end up with pulleys that are almost a metre apart, because you've got to have space for all this sort of stuff. In Celeb, you spy on the stars flying a drone around a Beverly Hills mansion. The drone itself is mounted on linear guide rails and moved by the little tooth belts. In this case, there wasn't space for the sprockets to be much further apart than the travel of the drone. So this is my space-saving way of joining the chain and fixing the attachment. This little lump of copper, it's actually a copper ferrule that's really intended for joining wire rope. So you push the tooth belt into it on both sides so it overlaps, and then squash it in a vise. I wouldn't advise copying exactly what I did. This is 6mm wide bolt, and this ferrules for 2mm wire rope, and it's a real squash getting the tooth belt in. You can get ferrules for 2.5 and 3mm, and then I think it'd be a good solution. The final thing is this pin that sticks out the side, and that's for the attachment, if you like. That's what engages with the linear bearings that drive the drone around. So although it's usually an advantage that a chain and tooth belt can't slip, there are exceptions. So in the clock I made for the Exploratorium, each chain is connected to 6 different mechanisms. I was worried that if any one mechanism got jammed, it would stop the whole thing working. So the answer was to have a bit of slip, and to do that I fitted these things called torque limiters on each of the mechanisms. So now if I just hold on to the chain, I can stop it moving. So how it works is that the sprocket is actually gripped against 2 fibre washers, and according to how tightly it's held adjusts the torque. You adjust it with this big nut on the outside, so if I slacken it off then there'll be very little torque indeed, and if I tighten it up obviously the torque increases, and the adjustment is very precise, so you can really set it to exactly the torque you want. Probably can't, no, I can't hold it now. They're brilliant devices. You can make your own, which I quite often do. There's not quite the same precision of adjustment, but really you just need to put a shoulder on a shaft and a bit of thread, and then you put your sprocket on, another washer. Then the only special things you have to buy are these they're slightly dished spring washers called Belleville washers, which I talk about in the spring episode of this series. So let's put 4 of them on there, so that they now push against the sprocket when I put a nut on the end. So just like the commercial one, according to how tightly I do up the nut, adjust the torque. Actually, I don't use an ordinary nut. I would use a nylock so that it can't come undone. If you don't need quite such precise adjustment of torque, but you still want something to slip, a much simpler alternative is just to use round belt. In the last 10 years I've got rather keen on mechanisms that can slip, really just to reduce wiring to avoid the need for limit switches. So on little light duty mechanisms, rather than having switches to turn off the motor when they reach the end of their travel, I just let the motor carry on and let the pulleys slip for a second or so. So I do it entirely on the timing of the motor rather than having the switches. Well, the downside is it is increasing the wear on the pulleys and the belt, but I've done it for 10 years and not have any problems. This is made of polyurethane, comes in lots of different sizes. There are many bigger, thicker ones than this, and also in different grades. I like the green one because it's pretty stiff, it doesn't stretch too much. Another common one is the orange one, which is a lot more elasticy. You can join these by just heating them up to weld them. I'll demonstrate in a minute. And I usually make my own sprockets for them. You can, this is acetal plastic or Delrin, and I also sometimes make them out of brass. I ground my own lathe tool to make the pulleys, The angle isn't that critical. I made mine 45 degrees just because it's the angle of traditional wedge V-bolt pulleys. Okay, so there are the pulleys in place, so now I can fit the belt. I just get this roughly to size, or line it up. Oops, there we go. I think cut it about there to leave room for a bit of stretch. So now we've got to join it. And I do that with this funny old Weller solder gun with a sort of flat bit that you can get for it. So now turn on the gun and just hold the ends of the belt, pushing them gently against the bit of the solder iron, and I think in a bit you should be able to see the polyurethane starting to melt. There it goes. So then you slip it off the end and hold the two sides together. I think that'll be all right now. So now I just need to go around removing the flashing. And there's the finished join. And it'll be very, very strong. I won't be able to break that. It's a good system. My funny old way of using the gun, I've got very used to it, but for a beginner it's probably a bit easier to make yourself a sort of jig. I mean, you can buy kits to do it, but they're really stupidly expensive, about 500 quid. So this is just a couple of bits of aluminium with butterfly knots on the back to clamp the belt in the right place, so that when they join with the heat gun between them, you can then push them together and know that they'll be lined up. Now we just have to fit the belt. That looks all right. Connect it up. And it runs perfectly well. The only trouble I've had with this round belt, it has occasionally broken when I've made the pulleys too small. The pulleys actually have to be 10 times bigger diameter than the belt itself. So in this case, that's a 50mm pulley with a 5mm belt. Proportionally, if I go down to say a 25mm pulley, that would just about take a 3mm belt. Oops. So even the tiny 2mm belt, you still can't have a pulley that's less than 20mm diameter. But actually, polyurethane belt's not nearly as bad as steel cable in this respect. Steel cable actually requires pulleys that are 40 times the diameter. I mean, you can get away with 20, but it reduces the life greatly. And that for a 2mm steel cable, you need a whopping 80mm pulley. And I have had trouble with that as well in the past, with steel cable fraying because of using two pulleys that are a bit too small. So really mustn't grumble about polyurethane in that respect. Well, I think that covers the basics of what I know about chain and belt drives. I hope you found something useful in the video. I'm such a fan of chain that a few years ago I decided to make an arcade machine that had lots of chain visible. And this eventually ended up as the fulfillment centre, my Amazon warehouse. So I'll leave you with a clip of a friend of mine using it.
Almost there. Only one more product to pick. But you've now been working 10 hours, so it's difficult to walk quite so fast. You don't have what it takes to work at the fulfilment centre. We are releasing you with immediate effect. Please collect the printout of your P45 form below. Don't be depressed. This is a fantastic career change opportunity, and as a gesture of gratitude,